Hey everybody, my name once again is Afolabi, and I'll be taking you through physics today. I've been receiving several comments about the previous videos. Let the comments keep coming, and as you are dropping the comments, we'll be updating the videos and reply you appropriately. Okay, today we have alternating current electricity. We have done previous videos concerning direct current electricity. Remember I told you that we have two types of electricity. Either you have the direct current electricity or you have the alternating current electricity. Okay, the direct current electricity is electricity in one direction. When you have current that has a unidirectional form of current, that's your direct current electricity. But today we are moving on to alternating current electricity, which is the other type of electricity. So your alternating current electricity is that type of electricity that is constantly changing direction. Okay, a form of electricity in which the current is constantly changing direction. So first of all, the definition. In terms of definition now, what is your alternating current? Alternating current electricity. Alternating current electricity is an electricity which currents or voltage value is constantly changing direction. Okay? For direct current electricity, the direction of the current or the voltage is unidirectional, that is, it is not changing. But when it comes to alternating current, which is AC, the current and the voltage constantly changes direction with time. So that means it is time dependent. AC is time dependent. That is, the value of the alternating current depends on time. At a particular time, the alternating current might be maximum. At another time, it could be minimum. And at another time, it could be flat. So your alternating current is time dependent. Okay? The sources of AC circuit or AC electricity, the sources that you can derive AC electricity from. We have limited sources. We have AC generator. You can get your alternating current from AC generator. You can also get it from the inverter. You can get it from the inverter. You can get it from the oscillators. You can also get it from your solar panels. All these can give you direct current. And of course from the mains. That's the government supply. That's the mains. Typically in a country like Nigeria, the mains come from the PACN. Okay, the one which you call NEPA initially. So any of these sources will give you the alternating current electricity, an electricity that is constantly changing direction. Now, one thing you should take note is that the alternating current electricity is very, very dangerous. In fact, that is why we say electricity is the most dangerous city, because the alternating current electricity can produce what? Electric shock. AC can lead to instant electric shock. Instant electric shock in human. Why is this so? Because it is constantly changing direction. So when alternating current electricity passes through the human body, the direction constantly changes, and that can lead to what? Instant harm to the brain cell. So your alternating current should not be joked with. Alternating current should not be something you use your bare hand to hold, and it can be gotten from any of these sources. That is in terms of the sources. Now let's move to the general representation of alternating current. The alternating current, as I told you, is time dependent. So that means that at a particular time, the general representation, at a particular time, it could be maximum. At a particular time, it could be maximum. We represent it in sinusoidal format. This is sinusoidal form. What sinusoidal means is that it's what? Like sine graph. So your alternating current is just like sine graph. This represents what? This represents the voltage or the current. Okay, why this represents the what? The time. So you can see that for me saying that the alternating current is time dependent, that simply means that at a particular time it could be maximum, at another time it could be minimum, at another time it could be flat or increasing or decreasing. So when you have a form of electricity in which the value is constantly changing with time, then you call this electricity, you call it the alternating current electricity. That's the graph. But in terms of, since you can represent it as a sine graph, then the general equation representing a alternating current can also be written in sine format. You have I t is I naught into what? Sine omega t plus or minus phi. Okay, that is for the current. That is for current. Then for voltage, we have Vt equal to V naught sine omega t plus or minus phi. We call these values, we call them the instantaneous values. Instantaneous values. So that shows you that what? The current at a particular time depends on the maximum current. This is the maximum current. We call these ones the peak values. Peak or maximum values. So the peak and the maximum values of the current, talking about what you have here. If it were to be a voltage, then this one will be the peak voltage. But if it were to be current, then this will be the peak current. So the value of the instantaneous current or instantaneous voltage depends solely on what? Depends on the maximum value of the current and voltage, and also it depends on the angular frequency of the vibration or the signal. The reason why I call it vibration or signal is that we all know that alternating current is a form of electrical signal. Good. So it is still a form of vibration. So that simply means we can represent it in what? In sinusoidal form. You can see this is a sine graph, and that's why I'm using sine here. This is the angular velocity or the angular frequency. This is the time. And this is the phase difference. We have where the omega is the angular frequency. Angular frequency, of course, we all know that angular frequency before now is what? 2 pi f. Okay, then the t is the time taken, and my phi is the phase angle. Now, all these tell us the instantaneous value of the voltage or the current. So you can see some will have positive, while some will have negative, depending on the direction of travel of the alternating current. Of course, you have been told here that your alternating current electricity is similar to alternating current signal. They are the same. So most of the things that we use in describing alternating current electricity are also the same thing that we use in describing alternating current signal, which is basically wave parameters. For example, we have the period, capital letter T, and that is the number of oscillations. Of course, this is one oscillation, this is another oscillation. So the time taken to complete a particular oscillation is your period. That is time taken to complete an oscillation. To complete an oscillation, that's your period. Okay, and the period T is the time taken to complete an oscillation, which is measured in seconds. N there is the number of oscillations that we have. Okay, so the time taken to complete a particular oscillation is the period of the signal. Another thing very close to that is used to describe a current electricity, alternating current electricity, is the frequency f, and that is just like the opposite of the period, and that is the number of oscillation completed in 1 second. Number of oscillation in 1 second. Number of oscillation in 1 second. So your frequency f is your n over t, the number of oscillation completed in 1 second. It's just like the opposite of this. So your f is definitely 1 over the period. If you look at the relationship between the two of them. The third thing is the angular frequency, which is different from the linear frequency, the one I talked about the other time, and that is what? The angular displacement, the rate of change of the angular displacement, rate of change in angular displacements. Okay, so our omega is 2 pi f. We actually got this from your simple harmonic motion concept. So your omega is 2 pi f, your f is 1 over t, and your period there is t over n. So after the angular frequency, we have other parameters that are used in describing alternating current. Another one is the peak value of the current and voltage, which I described earlier on from that equation. Peak value, which is the maximum value of the current and voltage in your alternating current. We also have the phase angle, which I mentioned there initially. This is the phase angle. And the value of the phase angle is the angular displacement between the alternating current and the alternating voltage. Most times when you have AC circuit, your voltage and your current are not always moving together. It is either one will be faster than the other or one will be slower than the other. But when the phase angle phi, when it is 0, that means the current and the voltage are in phase, which is in a very rare case. We are going to talk about that in our later video. Now, last but not the least, in terms of the parameter, is the RMS value. the root mean square value. Very, very important value in our AC circuit. Our root mean square value is the DC equivalent of an AC current. The DC equivalent of an AC value. Okay? When you measure AC, let's say you measure 50 amperes in your AC. When you take it to DC, what you get is the root mean square value. So it is the DC equivalent of an AC value, or you can call it the DC value of an AC value with the same heating effect. The DC value of an AC value with same heating effect, heating or lighting effect. So you have your voltage, RMS voltage, root mean square voltage. You also have your voltage, your current, root mean square. Okay, the root mean square voltage here is the peak voltage divided by square root of 2. It can be proved. Okay, while the current RMS is the peak current divided by root 2. So with these two, you can be able to find the AC equivalent, the DC equivalent of an AC value. These two are AC values, while these two are what? DC values. So to get the voltage, the root mean square voltage, all you need to do is to divide the peak voltage of an AC by root 2. To get the root mean square current, you divide the peak current by root 2. Don't forget to drop comments in this video, and we'll continue from there in our next video. Thank you.